Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal Irfan bin Muhammad Zubir, CD230013 from Group 7C. Will be presenting Introduction. Problem statement. Engineering economy is a compulsory course at UTSM and is challenging due to financial and numerical concepts. Students who struggle may experience poor academic performance, affecting yearly pass rates. Analyzing pass rates helps us evaluate students' performance and identify areas for improvement in teaching and assessment. Objective: determine the engineering economy pass rate at UTSM 2023 to 2024. Analyzing student performing using basic statistical method. Present pass or fail results using simple graphs. Apply basic hypothesis testing to evaluate pass rate.
Okay, Assalamualaikum. My name is Muhammad Shafiq Kamal. So I will talk about the methodology part. So the first one is the data collection and questionnaires. For this study, data was collected using an online questionnaire through Google Form. So the survey involved undergraduate engineering student at UTSM who had taken the engineering economy course. So a total of 100 valid response were obtained, while incomplete or invalid response were excluded to ensure the data reliability. So the questionnaire covers student pass or fail status, overall course performance, assessment component such as an exam and assignment, and basic background information. So next is data analysis. So the collected data was analyzed using basic statistical method to study the pass rate of distribution for the engineering economy course. So the descriptive statistics such as like frequency, percentage, mean, standard deviation were used to summarize the data. So visual tools like pie chart and histogram were generated using the Google form that we have created. So next is statistical method. So we are using binomial and Poisson distribution were applied for sampling analysis, and confidence interval were used to estimate the single mean, and then we are using a histogram also. So all the detailed result of this is included in the appendix A. So that's all from me. So we go to the next part.
Assalamualaikum and a very good morning to Dr. Asrina. My name is Muhammad Syahrizal bin Ahmad and I'm going to present about our result discussion for the descriptive statistic part. So, for the descriptive statistic part, our title is Statistical Analysis of Student Performance for the Engineering Economic Course at University of Nusa Tenggara for the 2023 and 2024 academic session. So, we collect our data by data overview, which analyze the result of 100 students. So we use histogram method for finding our data distribution. So basically, histogram is a connected bar plot with bar height proportional to the frequency of the associated value or class. So as Doctor can see, we already arranged 100 marks in the table from the data that we collect. So next, here we organize the data into 10 class intervals, each with a width of 6 marks. So as everyone can see, we also include the formula that we use when we're finding the number of intervals, we find the limits, we finding the mean, and many more. So our score range from a lower limit of 33 to an upper limit of 93. As you can see in the table, we also track the frequency, which is the relative frequency, and a cumulative frequency to get a complete picture of the grade distribution. Okay. So from the calculation, we know that the calculated mean score is 73.72, and also we record a variance of 218.113, and the standard deviation for this data is 14.77. So this helps us to understand the spread of mark across the group. So looking to the current slide, So here we have two tables, which is the first one is the table for the class boundaries frequency, relative frequency, and also the cumulative frequency. So looking at the histogram, we observe there's a clear left skew distribution, or known as skew to the left. So this means that instead of standard bell curve, the frequency increase progressively as we move toward the higher score ranges. So here we also notice the highest concentration of student falls between 69 and 93 marks, with the largest group of 23 students scoring in the top of bracket, 87 to 93 marks. So for the conclusion, the histogram graph show a rapid accumulation of students attaining higher marks, which this indicate the pattern to overall strong academic performance and a very favorable pass rate for this year students' marks. So thank you and for your time, and that's all for me. Next, I will pass to my friends.
Assalamualaikum, my name is Muhammad Daniel Iskandar. My metric number is CD23006. Today I'm presenting a case study using a binomial distribution. Binomial is used when we have a fixed number of a trial, only two outcome, pass or fail, and the probability of success is constant. The formula is we can see at the slide. Here n is a number of trials, x is number of success, p is probability of passing, and q equal to 1 minus p is probability of failing. The symbol on the right show meaning like at least, and the most, which is we use in equation. In UTHM engineering economy, the probability a student pass is 0.7. If we select 5 students, then x equal to number of students who pass. Number one is at least all 5 pass. First, the probability all 5 pass is 0.1681. So about 16.8% chance everyone pass. Next is at least 3 pass. Next, at least 3 pass mean x greater than 3. So the answer is about 0.8396, meaning around 83.7 chance that 3 or more student pass. Number 3 is at most 2 pass. Then at most 2 means x lower than 2. So the answer is 0.1631. So about 16.3% chance 2 or fewer pass. Number 4 is expected value. Finally, the expected value is a number passing is using mu equal to NP, and the answer is 3.5. So typically about 3 to 4 students pass. I will summarize the result clearly. Binomial summary. To conclude, 5 students with 70% pass probability each. All pass is 0.1681, about 60.8%. At least 3 pass is 0.8369, about 83.7%. At 2 pass is 0.1631, about 16.3%. Expected pass is a 3.5 student, around 3 to 5 student. This show the class is more likely to have a majority pass. That's all. Thank you.
Greetings to our lecturer, Dr. Hasina, and my fellow classmates. The part I'm doing is estimation. To do the estimation, first we have to pick the correct formula, that is the mean equation from methodology 2.8 and change it to confidence level equation 2.9. Next, we have to find out the value and substitute into this formula. The values are sample equals to 100, mean equals to 73.72, deviation equals to 14.77. Then confidence level is 98%. There's no significance level, so we have to figure it out. That is using 1 minus the confidence level, and that is 1 minus 0.98, and you will get 0.02. To calculate the rejection region, we have to use significance level divided by 2, and you will get 0.01. Using table 4, we can find out the percentage point of this rejection level is 2.263. And finally, substitute all the value into methodology equation 2.9, and you will get the single mean is between 7 70.284 and 77.156. To get the accurate single mean, we have to rearrange the methodology equation in 2.8 to become the methodology equation 2.9. And finally, the accurate single mean we get is 72.273. According to the calculation above, statistical estimation was applied to analyze the student pass rates for the engineering economics course at University Tun Hussein On, Malaysia for the academic years 2023 to 2024. A sample of 100 students was used to estimate the population mean pass rate. Based on the corrected data, the sample mean was found to be 73.72 with a sample deviation of 14.77, indicating a moderate spread of student performance around the mean, using a 98% confidence level that is corresponding to a significance level alpha equals to 0.02, as the population standard is between 70.284 to 77.156. The estimation result indicate that the true population mean pass rate is likely to lie within this confidence level, providing strong statistical assurance due to the high confidence level used. The estimated single mean value of 72.273 calculated further supports that the overall student performance is close to the observed sample mean. The rejection margin of 0.01 reflects a stringent criterion for statistical decision making, reducing the likelihood of incorrect conclusions. Overall, the estimation analysis suggests that the average pass rate for engineering economy students at UTHM during 2023 to 2024 is consistently around the low to mid 70% range, offering a reliable quantitative basis for evaluating academic performance and supporting future educational planning and improvements.
Conclusion. The high pass rate 98% indicates that most students successfully achieve the course learning outcomes. Overall results reflect strong academic performance in engineering economy. The findings can support improvements in teaching strategies, assessment methods, and future course delivery.